Hi, Professor. Today, I am presenting the paper Tau Square Bench Evaluating Conversational Agents in a Dual Control Environment. This work introduces a benchmark to test the conversational AI agents in a setting where both the agent as well as the user can take actions using the tools. The main example domain is telecom customer support, like when a customer says my mobile data isn't working. So, the key idea behind is a good agent must not only listen and use tools and reason, but also guide the user step by step to do actions on their phone. So I'll basically go through the entire task, how the evaluation works, baseline results, as well as the challenges throughout this PPT. So moving ahead, the motivation for the dual control. Basically, in many older benchmarks, like it's a single control setup. So the agent does everything with tools and the user only talks. But in real tech support, the user must actually do things like toggle settings, reboot the phone, check icons, and so on. So the missing skill here is, can the agent communicate clearly and coordinate with an active user? So here is the overall overview of the Tau Square bench, wherein the first one is the dual control telecom domain, where both sides can use the tools, as the user as well as the agent. Second, an automatic task generator that creates lots of troubleshooting tasks instead of writing them by hand. Third is a user simulator that behaves more realistically because it is constrained by tools and state. And the fourth is a failure diagnosis approach to understand whether failures are from bad reasoning or bad coordination. So, yeah, the overall Tau Square bench is like a controlled lab test for real customer support conversations. Moving ahead with the task description, like basically the telecom troubleshooting over here. So it's let's say a customer might call and say my data doesn't work. The agent has career side tools like checking the CRM and the network settings. The user has device side tools as well, like the turning mobile data on or off, airplane mode, checking APN settings, and rebooting. But like both the sides change a shared world state, which you can like clearly understand from this architecture over here. So basically, what this architecture says is a user can use his tools and the device side tools and send message to the agent, as well as the agent can do the same thing by using the career side tools. The database of user and agent both share the same shared world state, and here both are over there, and whatever changes are done are saved in this interaction history down over here. And then finally, the evaluator comes into picture, wherein we use the assertion functions to check the final state, whether it is a success or a fail, and also check the compute the number of passes to check the reliability. So moving ahead, the agent interaction model. So it is a two-player architecture basically. So there are two players, the agent and the user. They take the turns, and like in each turn they do only one thing, either send a message or a call, a tool, and not both of them at a time. So the state includes everything important: the databases, conversation history, and phone settings. And the overall goal is, through messages and tool calls, reach the correct final state where the issue is resolved. Moving ahead with the tools and policies, here we can see the agent tools, which are the career side tools, are, for example, let's say lookup, customer info, check or change network settings, enable roaming, check service status. And the user side tools, which is called the device side tools, are the toggle airplane mode, toggle mobile data, check APN settings, reboot phone. An important design idea is complexity asymmetry, wherein the user tools are limited on purpose because this would ask need the user to get the help from the agent. So basically, the agent must guide the user clearly and not assume it can directly control the phone. Here is a concrete example of the interaction. So it is a basically workflow types. So basically, the customer reports an issue saying my data doesn't work. Then the agent replies and asks the customer to check the phone status. The user goes ahead and sees like something like data is disabled, and then the agent again guides the user to toggle mobile data. The agent checks career settings, like roaming, and enables it if needed. The user then confirms it works now. This shows why the coordination is very, very important and why does it matter. Here is a step-by-step task generation workflow. So basically, it is divided into like three parts. Each task has basically three parts. So first is the init, wherein it sets up a bad starting state like airplane mode on, and then gives out the solution, the correct steps using like both the agent as well as the user actions, and then moves ahead to like use the assertions wherein a final check that confirms the world state is fixed. So by combining these building blocks, they have generated 2285 telecom tasks and evaluated on a balanced subset of 114 tasks. This makes the task scalable as well as automatically verifiable. So moving on to the metrics and success of evaluation criteria. So basically the main metric is number of passes, meaning how often the agent succeeds across k independent runs. For example, let's say pass 1 means it solved the task in one run, and whereas pass 4 means it solved in four runs. Very, very importantly, success is not just good conversation in telecommunication. It is like success is measured by the environment assertions. The final state must actually be correct. So here is the baseline setup of like did they test the agent. So basically they test the strong LLMs with function calling like the GPT models as well as the Claude, and the agent follows an instruction like let's say send a message or use a tool per turn. So the user simulator is also here an LLM, but it is constrained by tools as well as the state, and it mainly acts when the agent asks it to. So each task becomes a realistic back and forth tool here using the conversation. Here are some baseline performance results. So you can see like telecom is very, very harder. So these guys like tested the models on retail, airline as well as the telecom, and can clearly see that the telecom is harder. Let's say for example, the paper reports that the GPT 4.1 gets about 34% on the pass one on telecom. In retail and airline, the pass one is much higher than telecom. So the key message over here is like when the users can also take actions, agents struggle more because now they must coordinate, not just call tools. Here is some the ablation study analysis. So basically this is like very, very important slide of the entire PPT because it explains why telecom is harder. So they test three modes. So one is the default, wherein the normal dual control is applied, like the agent and user both acts. And then comes the no user mode, wherein there is no involvement of user and the agent controls everything on its own. Third is the oracle plan, wherein the agent is given the correct steps, so reasoning is basically easier. The big result out of this is like the performance drops a lot from no user to default. So an example over here from the paper is GPT 4.1 drops from 0.52% to 0.34, like in the first pass. So coordination and communication are the major bottlenecks over here. So moving on to the challenges and like the tasks over here. So as tasks require more steps, success drops. This paper shows that beyond about 7 actions, success in default mode becomes very, very low. Also, harder issue types fail more, like the mobile data and MMS compared to simple service checks. And also, the multi step dependencies are quite hard because sometimes you must fix service before mobile data works. So, here the basic benchmark reveals that long troubleshooting workflows are still a big weakness. Moving on to the error cases and simulator quality of this paper. So they report like this simulator error rates, wherein the telecom is around 16%, retail is 40%, and airline is around 47%. Telecom, we can see that is more reliable just because the tools are more constrained, so the user can't easily hallucinate actions. A concrete error example is like the premature termination. The user says transfer before the agent actually calls the transfer tool. So even simulator behavior is studied carefully in this benchmark. So finally, like concluding the slides, I would like to say that the Tau Square bench is a benchmark that tests both the reasoning as well as coordination in real text support styles tasks. And the key finding here is that the dual control causes a big performance drop, meaning the coordination with an active user is a major bottleneck over here. The future work of these guys says that like it includes testing more domains ahead and improving how we model beginner versus the expert users, improving the user realism, as well as developing better coordination strategies. So yeah, this is it from my side, and hope you enjoyed this presentation, and thank you so much for listening till here.